We have discussed the design philosophy involved in designing a PEB steel structure. Once the design is completed, the next most important step in a PEB construction is the fabrication in the factory. Generally, if you give this job to a well experienced PEB manufacturer, this part is generally done without much of a problem. However, quality control requirements are there also, which we will discuss separately. But the most difficult part, or the part where failures generally occur, is during the erection at the site. When a PEB is designed, as I have told you, PEB is designed with the at most optimum, to achieve the optimum economy. So there is no margin available for any error during the erection. So the erection is to be done in a well disciplined, pre-decided protocol. Any mistake, any error in this protocol or in this series may result in some of the members receiving a stress, undecided stress, in a direction which was not planned, or maybe at a location for which it is not designed. This may result in the failure of that member, and subsequently it will result in a series of failures of other members and a catastrophic failure at the end. So we have to follow a well disciplined erection protocol during the construction of a pre-engineered building structures. Firstly, it starts with positioning the anchor bolts at the right place. I suggest that whenever you are fixing your anchor bolts before pouring the concrete, if the erection is not done by the PEB manufacturer, you may insist that the the technical representative of the PEB manufacturer may come to site, check and confirm that the bolt positions you have put are accurate and correct, and only after getting that confirmation you should pour the concrete. If the erection is being done by PEB manufacturer himself, then of course he will check this point very accurately. Once bolts are fixed using proper templates, two things are to be seen within the template. The distance from bolt to bolt, that is the position of the one bolt with reference to another bolt, is to be accurate, which can be achieved by providing templates. Then distance between one column, that is one set of foundation bolts to the another set of foundation bolts, this is to be also to be maintained. This can be done by proper marking of the center line of the column in both the directions, in the horizontal direction as well as in the vertical direction. Means levels as well as the center to center distance between the bolt groups has to be accurately placed and checked and rechecked before pouring the concrete. After this is completed, we have to plan your lifting operation very correctly. A pre-lift meeting is always preferred, where all the people who are involved in the pre-lift in the lifting operation is involved, and the duties or the job of each of them should be very well explained, and they should know the location and position of the cranes, where the material will be laid out and how it will be moved, and crane and triggers are to be set prior to lifting. The boom length, the boom angle, the operating radius, the safe lifting capacity, this all shall be assessed very accurately before you start the lifting of the members. Crane is a very important factor in the erection of a PEB structure. The minimum height of the crane required is approximately equal to height of the rafter from the ground, that is the height of the structure from the ground, the maximum height up to which the rafter is to be lifted, plus 1/4 the length of the maximum length of the rafter you are going to lift. That is the minimum height of the crane required. The point of lifting of each of these members or the rafter as marked by the designer shall be strictly followed. If you are using nylon belts or closed slings, these are to be regularly checked for its strength, because when you are lifting it, it is most likely that some of these belts may get cut in the normal usage. So after every lift, this is to be regularly checked by an authorized person and certified that yes, this is safe to lift. Sufficient provision and appropriate use of temporary guys may be ensured during all stages of erection. Most of the PEB failures have happened because the proper guys are not provided, and due to lateral loads during the erection, it has started from one end, a failure has started from one end and the whole structure has toppled. This is a regular affair, this is a regular mode of failure in most of the PEBs where it has failed. All spanners and tools will be tied to the respective workmen. Falling of spanners and tools from top can be very, very dangerous. It is like a bullet. So all spanners, tools which are likely to move should be tied up so that under no condition it should fall down or fall onto another member. Generally we should start first with the braced base. Generally the end base or the base in between which are braced, we have to start the erection from this braced base. And this braced base, once it is erected, it should be suitably tied with the guy ropes. First, generally we erect all the columns, it is bolted, tightened to the base and connected with the guy ropes to support them in the lateral direction. Then complete bracings of that columns are completed. Then we should lift the rafter, and rafter segments shall be placed on the level ground and bolted together so that the full rafter length should be lifted as one piece or one member. Unless there is some other restraint, it is preferred that the complete rafter length from one column to the other column should be fixed, placed on the ground, bolted together and lifted as one set and placed in the right position. Lift the full length of the rafter to position, not part by part. The connection to be done after erection will be the connection from the rafter to the column only. The braced base will be tied with the guy ropes, held in position with the lifts till it is fully self-supporting. Remember that a single portal is never self-supporting. In the case of steel structure, as you all know, the structural stability comes from the interaction between the members, connectivity between the members, or the load transfer from one member to the another. So the structure becomes fully safe or self-standing only when all the members are erected, and that's how it is designed. So never imagine that one portal frame will stand by itself. No, it will be weaker in the other direction, and if you are not properly tied to the guy ropes supported by the cranes, it is likely to fail. This is how it starts. We first erect all the columns. As you can see, the columns are erected, bolted, fixed to the foundation. Then all the girts are fixed, the bracings are fixed, and once this is done, then the first portal is erected. Using two cranes, you can see it is erected in single piece and placed in position and bolted together. The cranes are not removed. Once it is bolted, then we will move on further. Remember that in case of any distortion in the portal during the erection, never try to force fit the portal. It has to be taken back to the factory, it has to be redone, it has to be, or a new portal has to be erected. Never try to force fit. In case of any distortion that is gone, that has to be referred back to the designer or given back to the factory. Never try to do any kind of force fitting at site. That is very, very important. Now you can see, now the guy ropes are tied so that this portal is secured against any lateral distortions. Once this is done, still at least one crane should be there to support it, and then the second portal is erected and all the purlins are fixed, placed in position, tied, and that is also supported by the guy ropes, and then we will go for the bracing. Now the first portal is fully connected with all the members, interacting members within that. You can see the first portal, the second portal in between, all the purlins are fixed, all the sag rods are fixed, all the bracings are fixed, tie level bracing at the rafter level, and column bracings are fixed, wind bracings are fixed, everything is tightened. So the first portal is now safe, but still we are not removing the guy ropes, because the designer might have done that there is a load transfer from first portal to second portal, third portal also. So now the third portal beam is erected. We have connected the purlins, and that is also tied up, then the guy ropes from the first portal, variable portal, can be removed if required. Preferably it can remain also. Then after this process continues from one end to the other. In case there are some portals in between which is also braced, that is done prior to putting the portal in between. To remember that the whole procedure, whole protocol is basically to avoid any distortion of any member during erection. Especially the guards, the purlins, the guards, they will not be able to take even the self weight. So the sag rods on the guard, horizontal guards, are to be connected, and at the earliest occasion sheets should be fixed. Once sheet is fixed, then the guards will remain in position. So this procedure, this is continued, and once the whole structure is completed like this, then you go for fixing the sheets, the roof sheet as well as the vertical sheet. This protocol is to be strictly followed while you are doing the PB structures. Again I am telling, in case you find any distortion in an individual member, don't try to force fit it, just discard it, get a new member, stop the work, get new member and progress. And safety of the workmen and the tools, because they are generally working at a bigger height, so that is also important during the erection. The cranes, the size, capacity of the cranes, stability of the cranes is very important. Whatever manufacturer of the crane has specified, the boom length, the radius of operation, that should be strictly followed. Many places the failure has happened because cranes have toppled or cranes have failed or the slings have broken. So these equipments, the load carrying equipments like cranes and slings, they are to be regularly checked. Never stress the crane beyond its limits. You should operate within the radius and height for which it is designed, and that only should be done. That is all for in this video. Thank you.